All right, let's look at another multiple choice. Now we're getting to the calculator options. So f prime of x equals this function, then f has a relative minimum at. So the first thing we want to do is graph the derivative. We get that in our calculator. We get something like this. So where I could see a mistake made on this is forgetting that we have graphed the derivative. I mean, I think they're doing a good job, not trying to trick you by saying minimum. Had they say maximum, maybe you'd think that they'd be talking about that point. But let's talk about what's going on in this problem. If it is the derivative goes increasing to here and then decreasing after, and the derivative is equal to 0 here and here. So when derivatives equal 0, that's when we have our extrema. So it's either going to be here or here. And because we're looking for a minimum, we want to go from negative to positive. So the only option for a minimum would be here. And if we use our calculator and go second calculate 0, we should get that guy right there. Now let's talk about the other points, just for the sake of it. This 0 here would be a maximum because it changes from positive to negative. And then when the derivative has a slope of 0, that's where we could have had a point of inflection. In this case, we would have a point of inflection because the derivative changes from increasing to decreasing around that point. So just a good review of everything we can find from a derivative. The graph shows the flow of water into the tank over a 12-hour period in gallons per hour. So we've got a rate, gallons per hour, which best approximates the total number of gallons. So we want the integral from 0 to 12 of that rate would give me the total. Now it is calculator active, but I don't have a function to integrate, and it says which best approximates. So we've got a number of ways from calculus to best approximate. I think you could use a left Riemann sum. I think that would totally be a good approximation. You could use a right Riemann sum, and it'd actually look a lot like the left. You could use a midpoint Riemann sum. That one might be pretty good, but we might be a little under right there. And then finally, we could also use a trapezoid. I would think any of those would be very good options. Whatever you choose. So let's choose trapezoid. And I'm going to use the trapezoidal rule because I've got equal intervals. So they're all going to have heights of 3. And then we also multiply by the 1/2. And then we go ahead and base 1, let's call that 190, is going to happen once. Base 2, let's call that 250. We've got 2 of those. Plus base 3, let's call that 380. We're going to use that twice. Base 4 is also, again, that 280 or 250. And then finally, our 190 again. Good. If you have any questions on the trapezoidal rule, just be sure to ask. But if we do end up calculating all that, I think we get 3210 from the calculator. So 3200. I believe if you used like right Riemann sums, you might have got like 3190. Like any estimate. I mean, I think even if you just use like a triangle, you'd get a number closer to that than any of the other ones. They wouldn't try to trick you on this, like just an understanding a geometry problem almost. All right. from 0 to 2 pi, let f prime equal e to the sine of 2x. On which of the following is the function concave down? So we have the derivative. Where is the function concave down? So let's say these words. If f prime is decreasing, that means f double prime is negative, meaning its derivative is negative, which also means f is concave down. All right, so let's take a look. I would just graph the first derivative that it gives us right in my calculator. I think it looks something like this. I'd say something like that. That looks pretty decent. This might be like 2 pi out here. So where is f prime decreasing? Looks like it's decreasing from there to there, and from there to there. And it's definitely not decreasing at 0, so I would cross off, oops, not those. Oh yeah, those. Sure. Really, those all involve from 0 to a point, so those are all away. And then, yeah, I guess I would just calculate the maximum right there, which I believe is 0.785. Therefore, that's our only option. Didn't really have to calculate much more than that. We could kind of just eliminate. All right, another interpret of the graph of a derivative, which is kind of very similar to the one we just looked at. The graph of f prime, the derivative of f, is shown in the figure above. The function f has a point of inflection at x equals, and again, let's talk about this. For f to have a point of inflection, its second derivative has to be equal to 0. The second derivative is related to the first derivative. F double prime is the slope of f prime. So we're looking for when is the slope of f prime equal to 0. And that happens here, here, and here. And it's really that straightforward. Unless it just has, unless it doesn't go from decreasing, which, take a look. It goes from decreasing to increasing, increasing to decreasing, and decreasing to increasing. So all of those would in fact be points of inflection, because the derivative change went from negative to positive to negative to positive. So Q, S, and T would all be good points of inflection. If f prime is less than 0 for all real numbers x, and I believe this is the integral from 2 to 6 of f of x dx is 0, which of the following could be a table of values for the function f? Good. So we're looking at some data from a table. So if the derivative is decreasing and we want a table for the function, that means if the derivative is negative, that means the function is decreasing. So first, let's look to make sure which ones don't have a decreasing number. From 4 to 3 to 2, negative 2, that's all decreasing. Negative 4 to 6 is increasing, so that's out. 3 to 5 is increasing, that's out. This one is constant, so it's out. Negative 1 to negative 2 to negative 3, decreasing. So we've already gone to A and B, or A and E as our only options. Then we've got to look at our second piece of data, our second stipulation. The integral from 2 to 6 of the function has to equal 0. That means the area under the curve has to equal 0. So let's draw what that would have to look like. 2 to 6. for that area to be equal to 0, that would mean it would have to go from positive to negative, because these areas would have to cancel out and add to 0. And I have to draw it like that because it is decreasing. So this function is decreasing, but it definitely has to start positive in order to decrease and have all the area add to 0. So which one, of course, is that? This one starts in the negative and goes more negative, but all of its area from 2 to 6 would be negative area. So this is the only one that could possibly have the right area to add to 0. Good. Calc it up.